Let's get started with blob storage by taking a look at this from the storage account perspective. First of all, we have our storage account, and you'll need one that supports blob storage. In addition, we have our containers, which are inside our storage account. This helps us organize our various blobs and images and data files as we come across them. And finally, we have our blobs themselves, which go inside there. Now, you may be thinking, okay, what is a blob? How is this different? Well, blob is a binary large object. Think of it as your ones and zeros. These could be images, video files, random text files, or whatever they might be. But don't confuse them with files compared to like an SMB file share, for example, which has permissions and other things associated directly from a CIFS perspective. This is for storing large amounts of images, videos, etc. Now, if we look at the storage account types, we have three major types. We have GPV version 1, blob accounts, and GPV version 2. Now, GPV version 2 is the main choice you will use when you create storage accounts in Azure now, because it allows us to do page blobs, block blobs, so we can do all of our images, videos. We can also store VM disks in there as well. We can mix everything in a GPV2 account. GPV1 allowed us to store blobs and other disks as well, but a blob account was specific only for blob storage, and ultimately it was confusing for everybody, so that's going away, and GPV2 accounts are ultimately the direction going forward. You may be asking then, okay, well, what is the difference between a block blob and a page blob? So a block blob, again, is ideal for storing text or binary files. Again, those are those images and video files. A single block blob can contain up to 50,000 blocks of up to 100 meg each for a total size of 4.75 terabytes. So that's a single image. Ultimately, it could be 4.75 terabytes. Append blobs are also there, and they're optimized for append operations, example, for login. Now, you may see that difference between, blob creation and append blobs, and that's just 5 terabytes. So that's a single image. Ultimately could be 4.75 terabytes. Append blobs are also there, and they're optimized for append operations, example, for login. Now, you may see that difference between blob creation and append blobs, and that's just important from that perspective. Page blobs, on the flip side, these are for read-write operations. Think of your VM disks here. These are used by Azure VMs, and these can be up to 8 terabytes in size. Which leads us on to the next thing that we need to cover, which are storage tiers. We've decided now that we want to use blob storage and store a bunch of images, but what's the right tier to go for? Well, the first one we look at is hot storage. This has our highest storage costs, but our lowest access costs. So think of this for frequently accessed images that we might be utilizing in our application, or, maybe website content, things like that, accessed very periodically. Then we have cold storage. This has lower storage costs now, but higher access costs. And it is possible to move from cold to hot and hot to cold, as you'll see in some of the demos. But what you do incur is a storage cost penalty when you do that, because if you're moving from cold to hot, immediately you're going to pay those higher access costs for accessing the cold storage as you move it to hot. So even though you can move them around, it's best to aim to use the right tier of storage for your purpose. And if you look at cold, it's really intended for data that will remain cool for 30 days or more to be cost effective. Finally, we have archive storage as well. This has our lowest storage costs, but our highest retrieval costs. When a blob is in archive storage, it is offline, and so cannot be read. And this is really because it's pushed off to tape or some other archive type storage that Microsoft uses on the back end. So if you decide you want to access something in archive storage, there is a period of time as that has to get rehydrated back so you can access it. Now, ultimately, just pick the right storage for your use case. And if you decide, okay, well, sometimes things go into hot storage and then eventually I want them to go to cold or eventually to archive, it is possible to enforce some auto-tiering around this that will gradually move, unaccessed blobs from hot down to cold, down to archive, and there's various automation techniques in Azure that allow this to take place. Finally, let's just take a look at the decision criteria as we try to choose between blobs, files, and disks. Often this gets very confusing. So if we break it down, blobs themselves, this is for storing large amounts of objects. Again, images, videos, etc. We might want to access them from anywhere. Just lots and lots of images, videos, text files, etc. that might be accessed. Then we've got files. So think of these as more from accessing from multiple machines, jump box scenarios. Maybe you've got a remote desktop that somebody wants to store a root user profile on. That's a good scenario. And then finally, we have disks. So these are really associated with our virtual machines attached to the operating system. Think of this for like lift and shift scenarios. When we're moving from on-premises, we might be doing disk expansion for application installations, lots and lots of read-writes. That's when we would ultimately use disks themselves. Now that concludes the overview, and I encourage you to check out the subsequent demo, especially as we kind of build blob storage accounts and move images around. You'll get a lot of feel for everything that we've covered thus far. In this demonstration, we're now going to cover creating a storage account via the Azure portal. So let's flip straight over to Azure. Here we are in Azure, and the first thing we're going to do is on the left, just go ahead and create a new resource group. So select resource groups, select add at the top, and type in your resource group name. So in my case, I'm going to use SL-storage. Choose your subscription and the resource group location. Again, this is just for metadata for the resource group itself. You can still put your storage account in any region you like. And go ahead and create that. The reason we do this and create our own resource group here is we can put all our storage accounts in there for demonstration purposes. Just delete the resource group when you're done and you've ultimately wiped everything out straight away. So within a few seconds that should be created if we hit refresh here. And there we go, SL-storage. Now we're going to that resource group and let's go in here and create a new storage account. So go ahead and select add. Type in storage account. You'll see it'll come up there, storage account, blob, file, table, queue, because that's what we can store in there. And go ahead and select that, create. And now we'll get the blade for creating our storage account. So first of all, let's go ahead and give it a name. So in my case, I'm going to use SL storage demo. And as you can see, this is a publicly addressable namespace that we need here, so it has to be unique. Then we choose the deployment model. For everything in this course, we'll ultimately be using the resource manager model, as you've probably seen so far. And then we get onto the storage account type. So if we go ahead and hit the drop down here, we can see we have storage, storage v2, and blob storage. And ultimately now everything we do, we're going to use a storage v2 account. Now you notice some of the options change below. If we go back and choose storage gv1, we don't get that option for the tier straight away. I'm going to switch back to it again. And you can see that there we get a default access tier. And this is because we can set a tier of storage at the storage account level, which will apply to all the objects underneath it. Now we can still change the individual blobs to have their own access tier, but this is quite a nice feature because we can say, okay, everything we want here, we might want cool, we might want hot. In my case, I'm going to choose hot, and everything underneath it will apply to. Then we can choose our performance. So we've got standard and premium, much like when we talked about virtual machine disks. You know, we can choose SSD type storage or standard spinning disk. In our case here, we'll just go for standard for the purposes of this demo. Next, we need to look at replication options, and we have the same four that we covered in the virtual machine section. LRS, which is a locally redundant storage. This is 3 copies locally in the same data center. We have ZRS, which is zone redundant storage. This is in preview currently. Still 3 copies, but in a zone-based region, so a couple of data centers in the same region. Geo-redundant storage, which is GRS. This is 6 copies across multiple regions. And finally, RA-GRS, which is read access geo-redundant storage that allows us to replicate to another region and actually read data there. It's basically warm and ready for us to access. In our case here, we'll simply select LRS. Next, we choose our access tier, as we already discussed. We're going to use the hot tier. And then we have options around secure transfer. If we open up the information on this one, this allows us to enforce encryption options for when we access in data from the storage account. For the purposes of this demo, we'll just choose disabled, choose your subscription, and select the resource group we just created previously. Finally, scroll down, select your location. In my case, I'm going to continue to use North Central US, and choose Disabled for virtual networks. This option, which will be covered in the networking section, is around virtual service endpoints, and that allows us to say, take a storage account, and instead of exposing it over the internet, we can expose it directly through a virtual network. And this is a way for security teams to buy off on the fact that, we have blob storage out there that's only inside of the Azure private network itself. With all those options selected, go ahead and click Create, and then we'll fast forward here. It should take about a minute for your account to be created, and we'll transition to once that's completed. As you can see, after a period of time, the storage account is now created, and we can go ahead and select it. Once it opens up, you can see the performance that we chose, which is standard, the replication set to LRS, and our account, which is set to GPv2. And then at the bottom, you can see our various services. So we've got blobs, files, tables, queues. If we wanted to go ahead and upload blobs, we could go into the blob section, create our container, and upload it from here. But you'll see in a subsequent demo, as we use Storage Explorer, how you can upload lots of blob images and manage your storage account from there. And with that, this concludes this demonstration. In this demo, we're now going to create a storage account via PowerShell. So let's head straight over to our PowerShell client, and let's begin. The first thing we need to do is make sure we have the right version of the Azure RM module available. You can check your current version by typing in get module space dash list available Azure RM. And once you hit enter, you'll see there module type script version 4.4.0, and you just need to make sure that you have version 3.6 or higher for you to be able to create storage accounts using PowerShell. The next thing we're going to need is our resource group, which we created already when we did it via the portal. So let's go ahead and do a get Azure RM resource group. And we can see there that we still have our resource group, SL-storage, and the metadata being in North Central US. Let's go ahead now and store that resource group in a variable. So let's type $resource group name equals SL storage. Hit enter. And now it's time for us to go ahead and create our new storage account. So use the following command: new-Azure-RM storage account. Then hit dash, resource group name. You can start typing it in, it'll fill it in for you. The variable for resource group name, followed by the name of our storage account, so dash name. I'm going to use SL storage P shell here to identify it as a different one from the one we created in the UI. Now we need to define the location, so we'll use North Central US. Next we need the SKU, so this is where we choose the type of disk and the type of replication we want. So if you type in dash SKU name, and then follow that up and type in, say, standard, and start tabbing through these, you can see you've got standard GRS, standard LRS, standard RA GRS, etc. And if you type premium in the beginning, it'll give you the LRS option, which is currently the only option for the premium disks. But if we go ahead and choose standard LRS there, and then finally choose the kind, in this case we're going to use storage as opposed to blob. Go ahead and hit enter, and we'll fast forward here. After a minute or so you should see that complete. And in a little while you'll get a screen like this to show that everything's completed and there's some details around the storage account itself. But let's now just go straight over to the Azure portal. And if we go over to our resource group, and do a refresh. In fact, we already see it there. So we've got SL storage P shell. Select that one there. And we can see at the top that we've created a standard LRS storage GPV version 1 storage account in this case. And if we want to, we can use PowerShell also to upgrade that to version 2. But let's just go over and select configuration from the settings panel on the left. And there you'll see immediately it shows the account kind as storage general purpose version 1. And if we want to, this is another place we can simply hit upgrade. Go ahead and confirm the upgrade. And to do that you need to type in the account name. So in this case it's SL storage P shell. Select upgrade. And that will go ahead and upgrade your storage account, and you can now see it is set to version 2. And with that, this concludes this demonstration. Alright, time for another demonstration, and now that we've created a lot of our storage accounts, whether we did it via the portal or via PowerShell, it's now time for us to be able to browse that storage and maybe upload objects, etc. to it. And so we're going to use the Storage Explorer client to do that. In order to begin, you first need to download the client, which you can find on the Azure website. If you head over to azure.microsoft.com/en-us/features/storage-explorer, or just Google Azure Storage Explorer, you'll be presented with this page. There's a Windows client, a Mac OS client, and a Linux client. Go ahead and download Storage Explorer free by selecting the link at the bottom after you've selected your OS. And once that's installed, we'll continue with this demonstration. Okay, so once Storage Explorer is installed and you'll immediately be prompted to run it, go ahead and do that and you'll be presented with the screen. You have a number of ways that you can log in and browse your storage. You can simply add an Azure account directly. You can use a connection string or a shared access signature that we'll learn about later on in the module here. And you can always use your storage account name and key as well. But in our case, we're just going to sign in by selecting sign in on the bottom here. And this will sign us in the usual prompt to sign into our Azure account. Okay, once it's added, simply select apply, and then you can see all of the various storage accounts. So in our case, we created a SL storage demo, first of all via the portal, and then we created one via PowerShell. So we can expand these out here and see what's inside them. Again, we really don't have anything in them at the moment, but you kind of get the idea there. Now what we can do is add some files directly to that. So we can take some images, for example, and then go ahead and select the blob container section under your storage account. So if we right click there and click create a new blob container, call this one images. And on the right hand side now we see we have this upload option, so we can go ahead and select that, click upload files. And now I'm simply going to select a folder full of files. I've got an image sample on my desktop, so I'm going to select all of these, select open, and go ahead and select upload. And what you'll see is this begin to start here in a moment, and on the bottom if we expand this out, we can see the group of images it's uploading, how many are complete, and you can see they're appearing in the top pane there as each one is uploaded. And so you can see the flexibility. It's just like managing a file share on your own machine, where you can create images, delete images, etc., create new folders. If you want to get a URL from them, if you want to rename them, you've got these whole series of options available to you on the top there. The other thing as well is if we go over to the Azure portal and look in our same storage account, so SL storage demo, we also have an option there, open in Explorer. So if we go ahead and select this and click yes, you'll see it'll switch apps and open directly in Storage Explorer as well. So this is another quick shortcut. If you're in the Azure portal and you want to open up in Storage Explorer, you can simply do that and it'll take you right across there. And with that, this concludes this demonstration. We're definitely covering a lot of details around storage here, and you might be thinking, are there other tools that Microsoft makes available to copy files, perhaps between blob storage accounts and different accounts, perhaps from your local machine to a storage account, etc. So let's walk you through a little bit of a demonstration here. But to begin, you first need to go ahead and download the tool AZ Copy from the Microsoft website. So here we are on the Microsoft website, and the first thing you need to go to is the Getting Started with AZ Copy webpage, which we've linked here for you as well. And this again is the command line utility that you can use to copy blobs or files to or from a storage account. Now you will notice that AZ Copy version 10 is the currently supported version. There was a version 8.1, and it was actually covered previously in my courses, but this is now updated to version 10. Everything we're going to do from here on out is version 10, so make sure you get in version 10 if you're following along. And what you need to do is scroll down. You'll see download AZ Copy, and you've got your Windows, your Linux, your Mac OS options here, and it's an executable file. There's nothing you need to install. What will happen is when you click this download link here and click save, it will download a zip file to your machine. Go ahead and open that folder, and what you will see when you open up the zip file, in the folder inside it, there's azcopy.exe, and again, all you need to do is copy that to somewhere you can execute that from. Very quickly, if you're not too familiar on Windows and how you do environment variables, I'll show you how I've done it in my case. So if I go to my C drive and I go to AZ Copy, I created a folder called AZ Copy, and I just copied that exe file straight in here. And then what I also did was change my environment variables. I can execute it from anywhere. In Windows, you can just hit the start menu and type environment. And you'll see it says edit the system environment variables. Click in that, and then click in environment variables at the bottom. You'll see here you have your user variables. These apply only to you on your machine, and your system variables that apply to everyone. In my case, if I scroll down in system variables, you'll see a section called path. And if you click path and click edit, this is all the locations that you can execute from directly. In my case at the bottom, I've got C:\\AZ copy. If you want to put it in a different folder, that's absolutely fine. You can browse to that folder when you want to execute, or you can just add it to your path by clicking the new button on the top here and put it in. So if you put it in C:temp or something, you would just put that in there, wherever you basically put it in, and then you'll be good to go. But I'm going to cancel out of that now, cancel out here, and open up a command prompt to show you how it works. And I've also saved a number of pre-filled in commands that I'm going to use throughout this demonstration. And so I've got them here in a text file. I've got AZ Copy login to my tenant ID. That's the first thing we're going to do. Now you don't have to always put the tenant ID in. You can just do AZ Copy login, but it will go to a default tenant, and you might get an error if you're not authorized in that tenant. In my case, I want to specifically log into this Azure Active Directory tenant, and that's why I've got the tenant ID there. If you haven't covered Azure Active Directory already, you can jump ahead and learn more about Azure AD, but otherwise just make sure you put your tenant ID in for the tenant you're trying to log into, and you will be just fine. We're then going to run through a number of other commands which I'll talk you through, but for now let's just go ahead and log in. So I'm going to open my command prompt, and I'm going to type in AZ Copy just to verify that I can actually grab the file. And you can see that it does work. It comes up to show me that I've got available commands, even though I'm not in the AZ Copy directory. Again, I put that in my C drive under AZ Copy, and there's our exe file. That's basically what's executing every time I type AZ Copy. But let's go ahead and log into that tenant. So I'm going to go grab my login command here and paste that in, and that will now log in. And you'll see it says go ahead to this page, microsoft.com/device login. So if we browse over there, and then enter the code that's in the command prompt. So here we go, grab this code and enter it in, and that now logs me in with Azure AD authentication. You can also log in, as you'll see on that page, using a SaaS token if you prefer. That's another option, but in my case I'm just going to log in with Azure AD here. Okay, so that's logged in. If I go back to my command prompt, and we can see login succeeded. And so now the next thing we need to do is just show you the layout of the lab area I've got for this one. So in the Azure portal now, I've created two storage accounts for this. These are simple storage accounts. One is in North Central US, one is in East US 2. One is called AZ Copy Demo, the other one is called AZ Copy Demo Target, and we're going to use them for different use cases. If I click into the first one, we're going to look at AZ Copy Demo. You'll see here that it's just running on LRS storage, so locally redundant storage. It's on the standard hot tier, and it's a GPV version 2 storage account, and that's all we really need to know about it. It's just a basic GPV2 storage account that I can then copy into. If I go into the blob section of services, I can create my container, and we'll create one here, and we'll just call it test container. And we'll say private, no anonymous access for this container, and click OK. So there's our test container. And now before I can start copying files in there, there's one other thing I need to do, which is make sure I have the storage blob contributor rights assigned. So if I go to access control and I go in here and click role assignments, and then go ahead and add a role assignment, add role assignment, and you'll see a select a role, and you can type in blob. It's probably the easiest way to get this, and you've got storage blob data contributor. Now, even though I'm a global admin, even though I'm a subscription admin, even though I created the storage account, Microsoft does now require that you specifically give access as storage blob data contributor in order to copy files into blob storage. And that's a recent change, but a very welcome one, because they want to make sure that all the data services are locked down by default, and you have to explicitly give permission for them. So we do need to add this role, and I'm going to go in and add myself to that role. That can take up to 5 minutes to take effect, and while that's going on, let's go ahead and look at the files we're going to be copying over. So if I go to AZ copy on my C drive and then go up one folder, I've got an images folder, and in there you can see I've got 3 images, 1, 2, 3 here, and I've got a subfolder called images subfolder, and if we go in there you can see I've got 1, 2, 3, 4 images in there as well. If I go back to my storage account and go back to that container, so if I scroll down, go to the blob service, and then select the container, test container, I don't have anything there presently. Now I've saved all my commands, ready to go, and we're going to use this one, AZ copy, the command task action we want to take, C:\images, and you can see the star there, so that indicates I want to copy everything in that directory, and I'm going to put it in AZ copy demo, that's our storage account, .blob.core.windows.net, because I'm not using any custom domain for that storage account, and I want to put it in the test container that we've created. So let's go ahead and give that a shot in the command prompt. Okay, here I am back in my command prompt, and I'm going to paste that command in and hit enter. And we can see it's copying 3 files up there right now. Now you might be asking why only 3. Well, we'll come back to that in a second. Let's go back over to the portal and just verify those 3 images went across. And if we refresh our container, yep, we can see 1, 2, 3 images there. Now if we go back to our command and we simply add recursive, switch to the command and hit enter, it will now go through the folder that we're copying from, look through the subfolders and copy those in as well. That's completed. If I go back to the portal, refresh, you can see I've got that images subfolder in there now, and I've got those additional images inside there as well. Well, now what if we want to copy all of this from this blob storage and container over to the other one in the other region? Well, let's go ahead and go back. We also need to give rights to that other blob account. So we'll go back to our storage accounts. I'm going to go to AZ copy demo target, identity and access management again, add that role assignment, click add, role assignment. Remember it's blob contributor that you need. And I'm going to assign myself to this storage account and click save. And now there's one more catch. So even though I've got rights on the target, and we know I can copy files from a local machine to a target using my Azure AD authentication, unfortunately Microsoft doesn't yet allow you to copy from the source without a SAS token using AZ copy. So what we need to do is go back again to our other storage account, select AZ copy demo, and then scroll down and select shared access signature. And we can choose all the services for now, but if you were doing this in an enterprise where you wanted to restrict, you would typically just create the SAS token for the services you need. But in my case, I don't need to worry about that. The only thing I just want to make sure of is that I do choose a time in the past here. So I always typically go back a day and then go ahead and generate my SAS token. And I'm not going to use any of the other settings, but just to clarify, in case anyone's wondering, so this is allowed IP addresses, so this is sources that can use that SAS token. Here are our protocol options for HTTPS only or HTTPS and HTTP, and this is our signing key again, so key 1 or key 2, and I can regenerate those keys. If I scroll back up on the left hand side, I can generate access keys in the access keys section, but obviously regenerating the key invalidates all the SAS tokens that were created with that key. But with that, we've got our SAS tokens, so I can copy this, which I'll grab here and paste that into my command. And we'll just scroll back and check that's okay. Yep, add an extra question mark there, which we already had, so I'll get rid of that. And then what I also need to do is add the source container, in my case, test container / and then we get our SAS token after that. So if we scroll through the beginning, we've got AZ copy. We want to copy everything from AZ copy demo in the test container with this SAS token that we just generated. Scroll all the way across, and we're copying to AZ copy demo target.blob.core.windows.net in test container as well. And if you haven't already done that, you do need to create a test container in the new storage account as well. And you can do that using the command AZ copy make. In my case, I can grab this command and paste that in. And we just need to change the storage account to be the target one, in my case, so AZ copy make. And in the target storage account, I want to create test container. Hit enter, and that is created. Now I grab my other command on the bottom here and paste that in, and let's see if it copies everything across. And that looks good. There's 7 penned-in files. They're already copied across. And if I go to the portal, select the target storage account, scroll down and choose the blob service, and you can see we have the exact same thing now in the target account in the other region. Test container inside there, 3 images here, 1, 2, 3, and our images subfolder in here as well. And we can click into one of these just to see what it is and download that one directly. Grab that there, and we should see one of our beautiful images that we used here for our demonstration. So with that, that concludes the demonstration on AZ copy. I do encourage you to go back to the website and just make yourself aware of the different commands and how to use them. You can click use with blobs here and scroll down, and you'll see a lot of examples very similar to the ones I've just gone through here with you. How to upload an individual file, a directory, how to copy from a storage account to another. Just take note of the notes sections, because there are those limitations that currently exist. As you saw when we're using Azure AD authentication, I can authenticate to copy to the target, but when I'm copying from my source storage account, I do need to use a SAS token. So make sure you're aware of SAS tokens, make sure you know how to use them, and hopefully this demonstration reinforces that for you as well. And with that, that's the end of AZ copy. Alright, so we've discussed a lot around the different storage types that are out there, and we've created blobs and things in the various demonstrations, but how do we control access to them? And the first one I want to bring your attention to is access policy specifically to the container. And on the container inside of your blob storage, you can set the public access level. Now the default is private, so this is no anonymous access, nobody can access your images, etc. When things are set to private. The next one is blob, which I used for some of the demonstrations where we have anonymous read access for blobs only. And the third one is container, where we have public access for the container as a whole, so that's read access for the containers and the blobs. Now if we go further into this, we can also get a little bit more granular with SAS, which is shared access signatures. We may not want to just generically assign permissions at the container level, so we can use this method, which is a query string that we add onto the URL of a storage resource, and this string informs Azure of what access should be granted. And we'll get a little bit deeper into the shared access signatures and how you construct them in a little while. But to go a little bit further, there's 2 types. There's account SAS tokens. These are granted at the account level to grant permissions to services within the account. And then there's specific service SAS tokens. These grant access to a specific service within a storage account. And it should be noted that these are all encrypted. They utilize a hash-based message authentication to keep everything nice and secure. So what does a SAS token really look like? And if we break it down, when you copy it from Azure and you say, hey, I want my SAS token, it's going to give you a very long URI. That's a unique resource identifier. And there's a couple of things to keep in mind here. So you've got your storage resource URI. So in my case, I've got slsasdemo.blob.core.windows.net. That's my storage account, my images container, and then image.jpg. That's my specific blob that I'm referencing. And then I have this giant string that's appended to it, which is my SAS token as a whole. And it helps if we go ahead and just break that piece down further. So to begin, let's start with our blob that we know we have our image.jpg. That's the first part of the entire URI. Then we have the storage service version. So this must be set to version 2015-04 for April-05 or later for it to work at the moment. That's the current as of the documentation. And then we have SS equals BFQT. Now, it's very simple, actually. If you look at the B, that stands for blob, the F is for file, the Q is for queue, the queue service, and T is for table. So these are the signed services which are accessible with the account SaaS. Then we have SRT, in my case, equals SCO. So these are the signed resource types. So the S under SCO stands for service. So this is access to service level APIs. The C is for container, so access to container level APIs. And then finally, we have the object itself. So this could be the blob, or in the case of a table, could be the table, could be queue messages, etc. Then we go down a little further and we have signed permissions. So this is a bit of a mouthful here. We've got R, W, D, L, A, C, U, P. Well, let's break these down. So if we take the R, that's for read. So that allows us to read and essentially have read access to the object. The W is for write access. The D is for delete. The L is for list. A is for add. C is for create. U is for update. And P is for process. That's specific for queue messages. The same for update. That's specific for queue messages. If we go a little further, then we have our signed, expiry, and start. So the SE is the expiration date and time for this SAS, and the ST is the start time. Finally, we got signed protocol. So we're going to say in this case, we've got HTTPS as the signed protocol. And finally, as you can see, we have signature, which is SIG equals, and then the whole hash that we have after it. And that's really important because this is used to authenticate the request made with the shared access signature. So hopefully you can see, when you look at it as a whole, it's like, oh my God, what am I getting into? But now if you look at it, you can say, okay, this is really just breaking down. These are the permissions. This is kind of identifying what you can do on the object or what it can do on the container. And, the signature is what really authenticates the whole thing at the end. Now you might be thinking, well, that's great, but this could get a little bit cumbersome managing all of these shared access signatures that are out there. And so Azure provides something called stored access policies. And this is a method for control in SaaS. It's a group shared access signatures and provides additional restrictions. Now the good thing is they can be used to change the start time, expiry time, permissions, or you can even revoke it after it has been issued. It is, however, only supported on server SaaS. So for blob containers, file shares, queues, tables, etc., but not on the storage account as a whole. And you'll see how we configure that in the subsequent demonstration. But hopefully overall, this gives you an idea of some of the ways you can manage access, but check out the demo, and then hopefully that'll kind of solidify the knowledge you need for the exam here. Let's go ahead now in this demonstration and create and manage our shared access signatures. So let's head over to the Azure portal, and in the portal, we're going to use the storage account SAS demo. So we'll select that one. And in there on the left-hand side, you can see we have our access keys and shared access signatures. So I'm going to show you access keys first of all. This is very important because you have two access keys associated with your storage account. And if you want to, at any point, you can regenerate your keys. Now, the reason they give you two is because if you need to regenerate your key, you can move everything over to key 2, make sure everything's working, then regenerate key 1. Because what happens is when you regenerate your keys, all those shared access signatures that we create will no longer work. Now, if we go over to shared access signature, we can now create one for, let's say, our blob store. So we can say, okay, we want to allow services for blob, but we don't want file, queue, and table. We're going to give full permissions to the resource. And if we scroll down, now we select the start and expiration date. So hopefully you saw in the previous module description around our shared access signatures, this is where it'll create that start and end time. And sometimes it helps just to create one an hour in the past for your start time, so you know it's immediately going to be accessible, actually even further, just depending on your time zone if you're worried about that. You next have a section on allowed IP addresses. So if we want to restrict access to specific IP addresses, we can do that here. This could be a single IP or it can be a range. Our allowed protocols, so HTTPS only is the most common. And then you can see at the bottom here, we have the signing key. So we can choose to sign this shared access signature with key 1 or key 2. And as long as we don't regenerate that key, this shared access signature will continue to work. So let's go ahead. Let's use key 1. Let's generate the SAS. And then if we scroll further down, you can see our SAS token and our specific blob service SAS URL. So we could grab this token now. If I hit it there, go ahead and put it into one of our images that we have in already loaded. And let's go ahead and grab that image.jpg, paste our token there at the end, and our image comes up using the SAS token that we've created. But this can obviously be a little bit cumbersome because, we've got to now manage this shared access signature. Would have created 10, 20, 30, 40, 50 of these. How do we sort of deal with that? And so the policies that I mentioned previously are a great way to do this. And if we go over to Storage Explorer, in Storage Explorer, we can right-click our container and we can select Manage Access Policy. So in the section, we can create a new access policy. We can give it a name. So let's call it images 1 day as an example. We'll start it today. We'll end it to 24/2018 in this example. I choose the permissions again at this point, and I select save. Now, by itself, the policy doesn't actually do anything. What I need to do is when I create my shared access signature from Storage Explorer, I can reference that specific policy. So now if I go back over to the container, right click it and choose Get Shared Access Signature. At this point, I can drop down and select my access policy, and it's going to put in the start and the expiration time as well as the permissions that I selected in the policy, and I can go ahead and create that, and now I get that shared access signature, which ultimately is referencing, you can see there in the query string, the policy. And the good thing now is if I want to change the expiration date, I can simply go ahead and change the policy, and that's ultimately going to expire the shared access signature because it's relying on that policy. And with that, hopefully this gives you an idea of how you can control access to your containers, images, etc. using shared access signatures, but in combination with policy. The last thing we just want to cover briefly in this module is around encryption keys and Key Vault. And Key Vault is a service in Azure that you can use to store secrets and keys, etc. that you might want to use. And you could certainly take the key from the storage account, put it in Key Vault, and so when you want to access it, you open up the Key Vault, you get the key, and you use it from there. Now, for added assurance, when you use Azure Key Vault, you can also import or generate keys in hardware security modules. That's HSM. So on the bottom right of the screen on the slide here, what you see are the customer managed keys, which can be put in Azure Key Vault. They can be used to wrap and unwrap the wrapped account encryption key for something like storage service encryption, which ultimately is used under the covers for the storage account. And you'll see a little bit more about that later on. But for the purposes of the exam right now, know that you can use Azure Key Vault to store your keys, and know that it is possible to bring your own customer managed key as well. One of the other things you need to know for the exam is your ability to use custom domains for your URLs. For our storage account, we may not want it to be blob.core.windows.net as the domain suffix there. Say if I want to reference a specific blob, or perhaps I just want to be able to reference the container itself. And custom domains allows us to do this. And ultimately, you can do this for storage and CDN. So we can do it for blob.core.windows.net, or we could use it also for the Azure edge.net domain. And there are two ways ultimately to do this. At the end of the day, we're creating a DNS record with our DNS host provider that we're mapping a CNAME record there. And there's two ways, like I said, you can do your domain directly. This method is the simplest, but it results in a brief downtime because Azure has to verify the domain registration. Now, there is another way to do it, but it involves an intermediary step, and it's the use of the AS verify subdomain. So I could say take verify.skyline.com, pointed to asverify.sldscdemo.blob.core.windows.net. I know that's a bit of a mouthful, but once that step's completed, you can then create a record that points directly to sldscdemo.blob.core.windows.net. But there's no downtime now because we've already verified using that subdomain. So we've used verify.skyline.com temporarily, make sure Azure kind of recognizes our domain, does all the verification, and then everything's good to go from that point of view. So you just need to know that there's two options here for the exam. You may be asked, how do you eliminate downtime? And the answer is to use the AS verify subdomain. And, you may see a few questions on that. One of the key services in Azure right now is import and export, because there's a lot of data center migrations going on and the need to just get lots of data into Azure or out of Azure via disks instead of, say, uploading everything over the internet or via ExpressRoute that perhaps you don't want to saturate. And so there's a number of use cases for import export that you need to understand. One is for data migration to a cloud, speaks for itself. So, when you want to take that data from your data center, export it onto these hard drives, copy it onto these hard drives, and then ship it off to Microsoft, and then they will import it in, to Azure onto a blob store for you, so then you can, access it and move it around as you need to. Another use case is content distribution. Perhaps you've got a lot of data in Azure and you need to send it out to customer sites. That's one example there. Backing up, perhaps you're backing up your on-premises data to store it in Azure and you've just got a lot of data. Perhaps you want to archive, maybe things that you sent off on tape to another site once before, and you're going to bring all that back in and now maybe ship it off to Azure for, recovery in the future if you need to. And finally, data recovery, the reverse of that, perhaps I want to send that data back to recover it because I've been storing a lot of data in Azure, but now I've got a need to recover it. And so I could use the export service to get that data back to me. Now, there's a lot of components in the service itself. So one, we have the import-export service, which you access via the Azure portal, and that's used to track your data import, the upload jobs basically, or track the data export. These are the download jobs to you. The next service you've got is a command line tool, which is used for preparing disk drives that are shipped, copying data to your drive, encrypting data with BitLocker, generating drive journals, determining the number of drives. That's the WAI import tool that you will find, and that's the command line. You can just download that from Microsoft. There's version 1 of that for blob and version 2 for files. And finally, disk drives themselves. It supports HDDs and SSDs. There's import jobs where you ship the drive containing your data. And with export jobs, you're essentially going to send Microsoft empty drives that they will put the data on and then send back to you. Now, the supported disks and all that information is available on this link that's on screen, and again, will be in the course material for you. Now, if we go a little bit further and look at the job workflow, which this comes from the Microsoft site that you can see the link to on the bottom left. Think about this from beginning to end. You've got this creating phase, shipping phase, transferring, packaging, and completion phase. So creating, if we think about this way, number one, you prepare the drives using the import export client tool and you encrypt them with BitLocker. Then you create a job in the Azure portal, and then you ship the drives off to the Azure data center in that shipping phase. And then the carrier delivers the drives to the data center. It's all tracked and everything. You'll see all that in the service itself. The hard drives are then processed. So this is the transferring phase now, where Microsoft is processing the drives. The data is copied from the hard drives to the specific storage account that's indicated. And then the hard drives are packaged for return shipping back to you. They packaged up, shipped to you, and you effectively have completed the service then. The export job, a little bit different because you're basically shipping the drives to Azure first, then they transfer the data to them and then ship them back to you. But that essentially, is the service as a whole. And just make sure you understand it, know that different drives are supported, know how to get that information, and you'll probably get a few questions on the exam around this, perhaps around the use cases or perhaps just knowing how the service itself works in the portal. Before we get into the specifics of Azure Backup and Azure Site Recovery, it's worth first understanding the different business continuity strategies that are available. So the first one is high availability, and we talked a little bit about this in the virtual machines module. This is really the case where we run another instance of apps in the case of a catastrophic failure. So maybe a blade on the first rack of servers goes down, and we've got an availability set configured for our virtual machine. Well, that will fail over to another set of hardware. That's basically our high availability option. In addition, we have disaster recovery. This is where we run our app in a second data center so that if a failure occurs to the primary, the secondary is still online, the app will still continue to run. We might get a blip for some users that were connecting to that primary system, but through the load balancing technology, they would be rerouted to the secondary node. And then finally, we have backup itself, and this is where we want to restore data. So we might have our original set of data that's constantly being backed up, and then if something goes wrong with that data, we can restore it, or perhaps we want to restore the entire virtual machine. Perhaps in response to a disaster like the previous option, we could then just do a standard restore of that machine. Now, Azure Backup in particular is one of the products Microsoft provides you in Azure, and this is a backup solution that's been purposely built for the cloud and comes with a number of features. In particular, we've got unlimited scaling. Azure Backup will use the underlying power and scale of Azure Cloud to give you high availability, no maintenance or monitoring overhead. You can set up alerts, but there's no real overhead from your perspective to kind of scale up the system. In addition, you get unlimited data transfer as well. So Azure Backup does not limit the amount of inbound or outbound data that you can transfer, does not charge for the data that is transferred. However, if you decide to use some of these import-export services to import large amounts of data, then you might incur some costs at that point. But otherwise, it's a very cost-effective service to utilize. We also then have the multiple storage options as well. So it supports LRS and GRS. If you recall from the storage module, LRS is locally redundant storage. This is where it replicates your data 3 times in a storage scale unit in a data center. Or we can use GRS, which is geo-redundant storage. And this is the default and recommended option because it's basically taking your data to a secondary region. This is hundreds of miles away from the primary region. Costs more than LRS, but if a whole entire data center or region goes down, then you can still recover your data via the other region. Then we have long-term retention, so there's no limit to how long you can keep your data in what's called a recovery services vault that you'll learn more about. You can keep it as long as you like, but you are limited to 9,999 recovery points per protected instance, but that should be plenty for almost everybody's backup situations. Then we get application consistent backups. Now, I would say that Azure advertises this, but it does depend on which service you utilize, and you'll learn about the different services in a moment. Otherwise, they'll be crash consistent if you're not using any of those services in particular. And finally, data encryption, naturally, like a lot of other Azure storage services, is supported to allow for secure transmission and storage of your data in the public cloud. So let's take a look at the Azure Backup components that are available to you as well. Well, first of all, we have the Azure Backup Agent, also known as the Mars Agent. This allows for file level restore, system state restore. It's not really a VM backup, but you'll see this in one of the demos, but allows for file level kind of recovery of services for you. Then you have a couple of others which require servers. So you've got System Center DPM and Azure Backup Server. You might be using System Center DPM already on premises, and you can utilize that with Azure Backup. Azure Backup Recovery Services Vault would essentially become a target for DPM, and DPM stands for Data Protection Manager. It's a service a lot of people have been using for a long time. There's Azure Backup Server, which you can install on premises or in Azure as well if you like. And then finally, Azure does include an IaaS VM backup, which you will see in the demo as well. In fact, the course really calls for the first and the fourth option here. So we'll look at the Mars Agent recovery and the IaaS VM backup recovery in the subsequent demos to follow. Now, if you want to know about how all these different options compare, because it can get very confusing, simply head over to this link, which I'll select. And if you scroll down, you'll see a table, which I'll zoom into. And it says, which Azure Backup components should I use? And it breaks it down by the various options. So for the Azure Backup Mars Agent, what are the benefits? You can see it backs up files and folders. It's limited to Windows only, backup 3 times per day, and backups are stored in Recovery Services Vault. Scrolling down, you can get the details of DPM and all its extra features, Azure Backup Server and all its extra features, and then finally the IaaS VM backup as well and all of its features. So it's a good reference site if you're trying to figure out, well, which is the right option for me. But like I said, you'll see us demo the first and the fourth option coming up very shortly. Now, before we get into those demos, the last thing just to mention is a couple of the other recovery options. I already mentioned we've got Azure Site Recovery, we've got Azure Backup, but there are 2 other options that you can utilize as well. First one being Snapshot Recovery. So Snapshot Recovery utilizes the underlying blob storage. You can essentially do blob snapshots taken of your VM page blob. These can be copied into the same or different regions. You can create a storage account in another region and copy your snapshot across to it. And then you can basically get your VM from that snapshot. You create it from the snapshot itself. It can be application consistent, but only if the VM was shut down. So if you shut down a VM gracefully, take your snapshot, copy it to another region, instantiate that VM, it will be application consistent. Otherwise, it's essentially a crash consistent recovery option. The other option we have is geo-replication, and this essentially allows us to use the underlying Azure Storage GRS option, geo-redundant storage, which basically replicates our data to a region far away from the primary. And this allows us to then recover in the event of an outage to the entire region, or if we just had an outage and we wanted to recover from that data that's been replicated over there. It also has that RA GRS, that means it's read available, read access is the official term. There's an RA GRS option available, so if we wanted to, we could just take that geo-replicated virtual machine as an example and power it on in the other region that's warm and ready for us to go, or if we just wanted to read some of the data, we could do that as well. So these are 2 other options, a little bit more manual in operation. They're not really automated recovery options, although it is technically possible to do some of that with Azure Automation and PowerShell, but this essentially is more of a kind of a manual recovery type option. In this demonstration, we're now going to go about configuring Azure Backup, and then we're going to backup and restore a Windows VM. So let's head over to the Azure portal to begin. Alright, in the Azure portal, you can see I've already created a virtual machine, SL Backup VM01. This is just a Windows 2016 VM that we're going to use to simulate our backup a little bit later on. Nothing special yet, just a VM we've built from the marketplace. So to begin, let's go ahead and create a resource and type in backup. And we get Backup and Site Recovery OMS. Select that one. And this is where we can create our Recovery Services Vault. So we go ahead and click Create. And we'll give it a name, so we'll call it SL-Recovery Vault. Choose our subscription, choose our resource group. So I'm going to use SL-Recovery for this one. And then our location, which I'm going to put in East US for the purposes of this demo. That's also where I put my virtual machine. So go ahead and click Create. This sets up the vault for you, and it's pretty quick. Should only take a few seconds, hopefully, to complete this. And that's completed. Let's go ahead to that resource, and we can see our Recovery Services Vault, and currently nothing is being backed up because we obviously just created this vault. You'll see on the top that we have these options for backup and replicate. So we're going to do backup first of all. You'll see replicating some of the site recovery options later on as well. But go ahead and click backup, and once you're in there, you'll see the first option is where is your workload running. So you get to choose between Azure or on-premises. And I'll just show you the on-premises options quickly. We're going to use one of them in the other demo. But when you choose on-premises and you select, okay, what do you want to back up? If it's files or folders, Select that and click Prepare Infrastructure. You'll see that you get the option to download the Recovery Services agent. That's the Mars agent that I mentioned in the tutorial section, and then Vault credentials and various other things that you'll see in the upcoming demo. But if we select this drop down again, you can see if I select like VMware Virtual Machines and click Prepare Infrastructure, you'll see I get options here for using System Center DPM or Azure Backup Server. Also mentioned both of those in the tutorial. We're not going to cover those in this course, but it's worth just knowing that those options are there if you need to get to them, because Microsoft will expect you to know what the different recovery options are. So hopefully this makes it more visual for you. If we go back though to virtual machines, so we go to Azure and then select virtual machine because we want to back up our virtual machine that's hosted in Azure. Click backup, and then we get on to the next section, which is to choose our backup policy. So there is a default policy which backs up daily at 2 p.m. and a default retention range. But if we go ahead and select this drop down, you can create your own backup policy. And this is one of the things I actually love about Azure Backup, because it's made backup very, very simple for us. You know, I can go in here and choose a policy. We'll call it SL policy, and then I can choose my backup frequency. So maybe I want to back up at night instead. So we'll go down to like, maybe 10 p.m. Make sure to set your appropriate time zone, obviously. So if we go to Central Time as an example, so 10 p.m. Central Time, so in Chicago that would be backed up, and then I get my different retention ranges as well. So you can see that, at 10 p.m. it's going to keep 180 days of that daily backup point. Here's my weekly backup point. We're going to keep that for 104 weeks, and I can choose to toggle this on or off if I want to. So if I don't want to configure retention of that weekly point, I'm good with just the dailies and the monthly that comes in, that's fine, but I can keep that weekly so I know that's there. Same for the monthly all the way down to yearly, and I can click OK once I'm happy with that. And then we go into the items to backup. So I've only got one virtual machine running right now, so I'll select that one, select virtual machines 1, select OK. It'll validate that, and then you basically enable backup. And that'll take probably a minute or so to complete, and we'll begin backing up at the next cycle for you. So if we go over to that, I'll just fast forward here for a moment and head over to the virtual machine. Okay, so yeah, we're on the virtual machine. I'm going to scroll down, and you'll see that you have an option under Operations called Backup. Simply select that, and you will see that this VM is now under backup via Azure Backup, and you can see that it's past the backup pre-check, but there's an initial backup pending, and if we want to, we can go ahead and simply select Backup Now. You can see that you also have the option to stop backup if you want to remove it completely from backup. We'll go ahead and select Backup Now, and we'll retain that one, whatever date you want to give it. Simply select OK, and that's going to trigger the backup process and back up that virtual machine. So again, I'm going to fast forward here. That's going to take a bit of time for it to complete the backup, and then we'll come back to it when it's completed. Alright, so as we can see on the backup job screen, the backup for SL Backup VM01 was completed. If I go back up to the virtual machine, so we'll head back to SL Backup VM01, and you can see there backup status, last backup status, success, and you can see at the bottom there also that it's in an application consistent status. Now, if I want to, I can choose to recover the whole VM, so I can click Restore VM, and this is where I choose my restore point. So I'll select that application consistent restore point, select OK, and then I can choose how I want to restore that virtual machine. So I have a few options. I can restore the disks, or I can create a virtual machine. So I can give it a new virtual machine name. So I can call it SL Recovered VM. Choose the resource group. I can put it in the same resource group if I want to, same network, etc. Go ahead and select OK. And then click Restore. And that will now begin restoring another copy of that virtual machine. So the original one is still running, but we're restoring an additional one with a different name. Now I can also, if I wish, do file recovery on that virtual machine. So I can select File Recovery, grab this, select my restore points. Again, I've only got the one that I just did recently. And then I can download script to browse and recover files. So I can click this download as executable. And then I essentially get this script that I can open up. I'll just save it on my desktop for the moment. And open folder, and essentially it's an application file that you can run inside the virtual machine you are backing up, and it will mount essentially the file system from that machine. And just like you'll see in the upcoming Mars agent demo, it essentially mounts a drive for you, and you can then browse the files on that machine itself. But we'll go back to the portal here for the moment, and we'll come out of the section, and we'll go ahead and look at the job for recovery. So if we click View All Jobs, we can see that restore job is in operation, and we'll come back to that when that's completed. Okay, and after a while, looks like this one took about 25 minutes. That restore has been completed. We can select that job, and on the right hand side we can see, if we scroll down, we transferred data from the vault and it created the restored machine. If I scroll back up, I can see that target VM name is SL-Recovered VM. So I can go ahead and go over to my virtual machines, and I should see now that I have a recovered VM. There it is, SL-recovered VM, and that essentially is my restore of the SL backup VM01. So the same as that Windows 2016 image that I created from the marketplace, we've just done it now as a recovery instead. So hopefully that kind of makes it clear how easy it is to backup and restore in Azure, particularly IaaS virtual machines. It's super easy to get up and running again. And that concludes this demonstration. In this demonstration, we're now going to go about configuring the Microsoft Azure Recovery Services Agent, also known as the MARS agent, to do some file level recovery from a local desktop machine. So let's head over to the Azure portal to get started. Okay, so we're in the Azure portal and I've still got my recovery vault set up, SL Recovery Vault. I'll select that one. Go ahead and select Backup at the top. And now I'm going to choose that my workload is running on premises. I'm actually going to use my local laptop for this example, and I want to just back up my files and folders up to Azure. So if we select that and then click Prepare Infrastructure, we'll get the option here, first of all, to download the Recovery Services agent. So let's go ahead and click that. That'll just download locally to my machine. Then you also need to download Vault credentials to register the server to the Vault. So these are credentials that will expire after 2 days, but are needed as part of the installation for the Recovery Services agent. So let's go ahead and download those as well. Okay, and both of those are downloaded. So I'm going to open up my downloads folder, and you can see I have my MARS agent installer and my Vault credentials. So I'm going to go ahead and double click the agent installer. And as you can see, that sort of does its installation process, and then you get your usual like Microsoft installation, questions that you get. Where do you want to install it? Where do you want cache location? So we'll go ahead and select next to both of these. We'll accept the defaults. We'll accept the defaults for the proxy configuration. We're not going to go through an internet proxy. We'll opt into Microsoft Updates and go ahead and install. And that'll take a few minutes. We'll jump ahead here until that's complete. Okay, and once complete, you go ahead and select Proceed to Registration. And this is where it asks for those Vault credentials. So we go ahead and select Browse, go to my Downloads folder, select Vault credentials, validates them, go ahead and select Next. Enter a passphrase. You can simply generate one if you prefer, so you can do that. And enter a location to save that passphrase. So I'm just going to save it on my desktop for right now. Go ahead and click Finish. And that now registers this local machine. This is just a Windows 10 desktop I'm on right now, and it's registering it with Azure Backup. Okay, so now that's configured and registered with Azure Backup. Go ahead and select Close. You'll see the checkbox is already selected there, so it's going to open up the Recovery Services agent. As soon as I click Close, here it comes. It's going to load up the policy information, check for updates, and now I simply need to go ahead and schedule backup. So on the right-hand side, I can click Schedule Backup. Wait for it to get policy information, and let's go through this wizard now as well. So hit Next to get started, and now I can add my items. So I can click Add, and let's say I want to back up my whole C drive, I can, or let's say I just want to back up, what's in my Downloads folder. So let's just take that as the example. So I'll go to Users, Myself, and I'm just going to take my Downloads folder for right now. Just got a various, downloads that I've done over time. Go ahead and click Next. Select your schedule, so day or week. So I can do 10 p.m. today if I want to. Select my retention policy, so I don't really want a weekly, monthly, or yearly retention, so I can uncheck those, but I could configure those if I wanted to. If this was a full server environment, obviously I would want that. Select Next. I can choose this option of automatically backing up over the network or offline backup, but I'm going to choose automatically over the network, but there are options there for offline backup as well. Go ahead and click Next and click Finish when we are done, and it's going to go ahead and create that backup schedule for all of those download files basically. So I'll go ahead and click Close, and if I look now, I can see on the right hand side I can back up now. So if I go ahead and select that, go ahead and click Backup, and you'll get a status update here, and it will basically begin transferring all of those files in my Downloads folder up to Azure. And now if I ever want to recover them later on, I basically can. So we'll fast forward here until this is complete. Okay, and that's successfully completed, so let's close that screen down. And now if I want to recover data on the right hand side, if I select that, you can see that I have an option to recover to this desktop or another server. I can select Next, I can choose individual files and folders, and now it will fetch those volumes that have been recovered. So if I select the volume, it was on my C drive, it's got a recovery point. I'm going to go ahead and mount that. Okay, and that's mounted it as a disk, so I can go ahead and select Browse, and you can see it's mounted it as my D drive on this machine. Click Browse, can open up that users folder. You can see my user account and Collie. Double click that. There's my downloads folder, and in there should be my two files, my Mars Agent installer and my recovery vault file as well that was in there. And those were backed up to Azure, and I basically brought them back down using the Mars Agent recovery feature. And with that, this concludes this demonstration, but I hope you also can see how useful this can be if you've got files and folders on your machine that you want to back up to Azure and keep them in the cloud. This is another way that you can utilize that. Right, with all those intros out of the way, let's dive straight into the meat now. And let's just take an introduction to virtual machines. For anybody that's not familiar with virtual machines, it helps to just think about how your computer operates, right? So you have some hardware, you have CPU, memory, and disk. And on top of that, you have your operating system. So this could be Microsoft Windows, could be Mac OS. And on top of that, we obviously have our applications that we install. Well, along came virtualization many years ago now, and the concept is still very similar. We still have our hardware, so we still have to run our application somewhere, and we have our CPU, memory, and disk, but we install something in between, which is the hypervisor. And on top of the hypervisor can live multiple operating systems with multiple applications. So instead of just running one operating system that may only get used 10% of the time, we can run multiple operating systems, make much more use out of that CPU, memory, and disk. And every single one of these is essentially our virtual machine. And when we're in Azure, we're basically doing the same thing. We don't manage the hypervisor on premises. You would typically manage something like VMware ESXi or Microsoft Hyper-V. But in the public cloud, Microsoft presents us with a whole bunch of options for provisioning our virtual machines. And that leads us onto a really, really cool thing, which is all of the VM types available to us. Typically on premises, we would have one or maybe two different variations of hosts, and every time Intel releases a new CPU, we would upgrade those hosts. But in the public cloud, because just the scale that they have, you have multiple choices available to you. So if we go through these, it's very important to understand and select the right instance type for your workload. The A series were the very first series that Microsoft introduced. They're divided up into basic and standard. So standard are actually our general purpose VMs, and then there's a basic version of the A series for testing and development. Then we get on to B, which I remember as B for burstable. These instances can burst to the full capacity of the CPU when needed, but you get a discount because you're not using the machine a lot of the time. So it's storing CPU credits, and then when it has to consume CPU, it can use those credits and use the full capacity of the CPU. Now, if you're going to use the CPU continuously, it's obviously not going to make sense because you're not going to store in credits, and you're going to get worse performance. But a very cost-effective option there, and I highly encourage people to use them during some of the labs and things as well. D is the general purpose ones. You'll see a lot of these around in the enterprise. And then we have memory optimized. These are the E series. You'll see there's some other memory optimized ones out there. This is the newest memory optimized series they brought out recently. This is a high memory to CPU core ratio. Then we go into the F series. Immediately after memory optimized is CPU optimized, and this is the reverse. So we have a high CPU core to memory ratio, and so it's kind of the opposite of the E series there. The G series, Microsoft calls this the Godzilla. At least that's what people tell me when I'm walking around, Microsoft Ignite in various conferences. Very large instances, hence the Godzilla name there for large databases, big data use cases. Then we got high performance compute, computational, molecular modeling, scientific applications. That's the H series. The L series is for storage. I remember this as L for LUN, like in the traditional sense of storage. And these are, storage optimized with a high disk throughput and high I/O. Then we got the M series, another very large memory series available. These go actually much, much larger than the E series. You can go up to 3.5 terabytes of RAM here. Then we have the N series. They're actually divided up into NV and NC, depending on the type you choose there and what configuration you require. But these are graphics card enabled instances. And finally, we have SAP HANA on Azure certified instances as well. So as you can see, just a ton to choose from that. And then we go into the specialization. So if you just got your head around, okay, I've got all these types, well, now there's different specializations, and you notice this in the way the instance types are written out. So for example, we've got S for premium storage. So if you see D series, you'll also see a DS version. So DSV2, that's a premium storage option there. We have the M specialization as well. That's for larger memory of a configuration type. So if, for example, we've got a standard A2, then you might see a standard A2M that just has more memory. And then the final one we have R, which is supports remote direct memory access, also known as RDMA. And you'll see that by things like H16MR as well. All right, so we have all of these various types and specializations, but how do we actually compare the CPU performance differences between the different types? We know some might have more CPU and more memory, but what do those cores actually equal in terms of actual performance? And so Azure Compute Units, also known as ACUs, are a way to compare CPU performance between different types and sizes of virtual machine. It's a Microsoft created performance benchmark, so they took one of their A series virtual machines and started it at 100, and then equate all your different other instance types to that one. And so essentially you can say, look, a VM with an ACU of 200 has twice the performance of a VM with an ACU of 100. And a good way to really look at all of this is to go to the OS reference documentation for Windows virtual machines or Linux virtual machines, and Microsoft will actually list all of these out for you. And these are actually great sites, just from a deployment aspect and revision for the exam. Highly encourage you to check them out. And if we go to the Windows one here, what we'll see as this pops up is a section called concepts in here. If we expand that out, you'll see VM types and sizes, but if you scroll a little bit further down in types and sizes, you'll see Azure Compute Units here. And if we expand this out, you can see here, the SKU families, A0, A1 to 4, and you can see here's the ACU number. So if we compare, say, anything in the A1 to 4, A5 to A7, these all got at 100. And if we go down to something, like a DS1, V2, the performance there is going to be 210. The other thing to note is, this 2-to-1 ratio that you'll see on the V3s and the DV3s and the EV3s. And this is because they are now hyper-threaded. So, for example, a DV2 might give you, 210 to 250 on the ACU number, but when you go up to the V3, you're actually getting less performance. So it's just something to keep in mind, as you start to, invest in your instance types in Azure. Definitely, compare these so you know what you're actually getting. Don't just go by the pricing calculator if it's something that you're doing that depends on CPU. Next, we need to cover one of the key parts of the curriculum as well, which is identifying supported workloads on Azure. And we'll start with the Windows ecosystem. If we look at the OSs first of all, and we look at pre-Windows 2008 R2, so these are things like Windows 2003, they are supported for deployment. However, you must bring your own image, and there's no marketplace support at all. And you also need to have your own custom support agreement. Microsoft's not going to give you any type of support for Windows 2003, via Azure. When we get to Windows 2008 R2, that is supported. However, there's a specific support matrix for server roles that you want to check. So just because Windows Server 2008 R2 is the OS is supported, you do need to check the matrix of server roles that you're going to install on top of the server and check that those are supported. Things like Windows Server 2012 supported. There's actually a data center version in the marketplace. Windows Server 2016 is supported. There's a data center and a nano version in the marketplace. And for desktop OSs, those are supported for Windows 10 Pro and Enterprise, which are available in the marketplace. And there's another link here that's very, very useful. And if you click on this one, it'll actually also give you details of other Microsoft Server software that's supported on Azure. So it goes beyond just the operating system. And if we scroll down a little bit on this web page, we can see things like Microsoft BizTalk Server, Microsoft Dynamics CRM. So within the Microsoft ecosystem, Dynamics CRM as an example, 2013 and later versions are supported. And they list these for a whole host of things. It's very common to run, Exchange, which is supported again for 2013 and later if you're not using Exchange Online. And there's some other options here as well. So this link will give you, any other information you need around the specific workloads that are supported. But for now, at least for the curriculum of the exam, you may get asked on these variations, but for the most part, I'd say just revise the operating systems and you should be good to go. As far as Linux supported distributions go, all the major ones are pretty much accounted for here. So we have CentOS, Debian, Oracle Linux, Red Hat Enterprise Linux, SUSE Linux, etc. And another link here you can go to if you need to check, what Linux distributions are endorsed. If we hit this link here, we can see it takes us to this page, and all of the current supported Linux distributions are here. So currently for Red Hat, it's 6.7 plus and 7.1 plus. So try to remember those. CentOS 6.3, 7.0, and SUSE 11 and 12 are supported as well. All right, so we might be thinking we've got our types, our various supported OS distributions. Can we do it anywhere? And the answer, unfortunately, is no. There are, in fact, regional limitations on services in Microsoft Azure. And the screenshot here, I'm just showing the various compute products that are available in the various regions. And if you just take a look at this, look at the B series as an example. It's available in East US and West US 2 only at the time of recording this course. A8 to A11 instances, only 4 regions those are available in. And so this is important to know. Just because you decided, hey, I want this particular type of instance, you need to make sure it's actually available in your region, because you're not going to onboard every single region necessarily to your organization. In addition, it's worth understanding region pairs. So East US is paired with West US, and what that means is when Microsoft does their patching, they will patch one of those regions, then the other one. They won't do those at the same time. If you don't use region pairs, and let's say you went North Central and East US, they could be patched at the same time. So in the rare event that there is an outage, you could have a global outage to your Azure infrastructure if those are the only two regions that you use. So it's worth also keeping in mind the region pairs as well. And finally, before we get into the demos, the last thing you just need to be aware of is restricted usernames that you'll see when we go into the demo as well. So, here is a general list, things like administrator, admin, user. A lot of this is common sense. You can't use these for your VM usernames when you create your Azure VMs. In this demonstration, we're going to look at creating a virtual machine from the Azure portal. So let's head over there to begin. And here we are in the Azure portal, and one of the things you might notice if you have built virtual machines before is things have changed a little bit over time, and Microsoft continues to change this part of the portal. But we can go ahead now and click virtual machines and see I've already got one virtual machine there. That's just a Linux virtual machine I've got running. I'm going to add another one. We're going to build a Windows virtual machine at this point. So I'm going to click Add. And straight away now you get the Create a Virtual Machine panel that pops up, and you'll see they've added these tabs now across the top to make it easier to go forward, come back, throughout the process in itself. If we go through though, click Subscription, you would choose your subscription that you want to provision this virtual machine into, and then choose the resource group that you want to use. Now I've already got a resource group created called AZ-Demo where VM01 is currently in, but I'm going to add another VM to that resource group, so we'll continue to use AZ-Demo. I now need to give it a virtual machine name. So in my case, I'm just going to call this VM Demo 01, and now I need to choose the region, so I can choose any of the Azure regions that I'm entitled to provision into. In my case, I'm going to choose East US, and next we have the availability options. Now if I click this, you will see that sometimes we will get availability zone, sometimes we will get availability set. So availability sets were covered in one of the lectures, and if you haven't jumped to that yet, feel free to jump ahead to availability sets. Availability sets are inside the same data center, but allows you to have two virtual machines in separate racks of power and network connectivity. Availability zones are in the same region, but they're in separate data centers in themselves. So it's another way to get additional redundancy. Now Microsoft is rolling these out gradually to all the regions. If you click this icon, it's blurred out a little bit there, but you can click the little blue thing that says view locations that support availability zones, and then you can choose those. But definitely encourage you to understand the differences between availability sets and availability zones, because Microsoft is really emphasizing availability zones going forward. Next, we choose the image. So I'm going to choose from a Windows or Linux image here. These are all the standard ones available to you, and I can choose Windows Server 2016 directly from this pane. Now note, if I wanted to see all the images, I can click Browse All Images and Disks. That will show me everything available to me from my marketplace, but in my case, I'm just going to do a 2016 data center server. Next, we move on to the size, so I can click Change Size here, and this will give me all the different VM sizing options available to me, and I can do various filters on these. I can get rid of these filters if I want to. I can add additional filters. Right now it's looking at general purpose with premium disk supported, small sizes right now, so that's why I'm only getting a handful right there. If I got rid of the small, it's going to certainly open it up to a lot more sizes that are available to me, and in some cases your subscription may just not support that, or perhaps you've also got a policy in place that doesn't allow you to choose specific VM types. But in my case, I'm going to go back up and I'm going to choose one of the B1s. I'm going to choose the B1 MS. That option there, that's a 1 CPU, 2 gig of RAM, supports 2 data disks, got a max IOPS of 800, includes a temporary storage drive with 4 gig on it, and it's using premium disks. And on the right, I can see my cost per month would be $15.40 estimated. Now, one thing to note with the B series, as you probably heard about when we did the lecture on VM types, the B series does use the concept of CPU credits. So when you do provision them up, they can take a little bit longer to build. The purpose of B series is really for web servers, so that, when they're not in use, they're generating credits. When they are in use, they're consuming from those credits, but you don't want to use them if you're running things at 100% all the time. However, they are very cheap to run for lab purposes. You've got like the B1S here, smaller memory version. You've got the B1MS, which is that double memory version of the B1, much cheaper to run, for the purposes of your lab. But again, they take a little bit longer to provision. But if you select one, then go ahead and click select, and then that takes you on to the next section. So now we need to include our administrator account. And you'll notice that things like admin aren't allowed. That's a restricted word. If I go back and I just type in, say, my name, that is allowed, and we can move forward with that. And then you can go ahead and type in your password. This is the Windows password to get into the machine. Once we've got all that typed in and the passwords matched, we can then move on to the inbound port rules. And this section is pretty important because if we want to RDP into the machine, say over the internet, we do need to expose that. So we can allow selected ports and we can choose the ports that we want to expose. So perhaps RDP is one I want to expose. This is great that they added this. Things aren't just open by default. You have to choose to allow those inbound ports to be open, and you can further lock them down using Azure Security Center and just-in-time access as well. But for right now, yep, just go ahead and select RDP if you do plan on connecting into the machine after you've deployed it, which you'll need for some of the subsequent demonstrations that we do. One thing to note is the one difference between Windows and Linux here is in Linux we could be prompted to generate a key and put that in here, or we could use a user account. Windows, we just use username and password for the administrator account. If we keep going down, the next thing we have is save money, which is save up to 49% if you already own an Azure license for that Windows server. So if you already have one, simply select yes and choose your license type. You have to confirm that you have software assurance for that, and that will reduce the cost that you pay for those Windows servers. So this is a great benefit. If you've got a lot of Windows machines that you move into Azure, you will get a cost benefit by already having that software assurance. But in my case, I don't, so I'm going to click no and then move on to the next panel, which is the disk section. So yeah, we have our disk types, and as you can see, this machine, because it is an S series, does support premium SSD as well as standard SSD and standard HDD as well. I'm going to just go ahead and choose premium SSD for my disks there, and then I can choose if I want to create and attach a new disk or attach an existing disk as well. So perhaps I deleted a machine, but I left behind a virtual hard disk that I want to attach to this machine. I could do that there. If I want to just go ahead and create a second disk, and here you can see I can choose my disk type. So if I want to use a different type to the one I used for the primary disk. So remember right now I've got that OS disk that's on premium SSD. I also have that temporary disk that's on a local disk associated with the host that the virtual machine runs on. So that has specific use cases where I want fast access to a locally cached disk. And then this disk, again, I can choose SSD, premium, standard SSD, or standard HDD. In my case, I'm just going to choose a standard HDD right now. Choose the name of that disk. That's the Azure name for the disk, not the name inside of Windows, the size, and then the source type. If I want to choose a snapshot or a blob that I already have of a VHD, I can do that. But in my case, this is just going to be an empty disk that I attach with this virtual machine. With that, I click OK. And then we scroll down a little bit further, and then I can move on to advanced pieces as well. So if I want to use manage disks, the default now is yes, that's what we always recommend. But if I wanted to manage the disks myself, I could choose no there if I wanted to. Next, we move on to networking. And in networking, first of all, you're going to see details around the network interface. So when you create a virtual machine, a network interface card is created for you and is associated with the virtual machine. I choose my virtual network that I want to connect this virtual machine to. So again, I could create a new virtual network or just connect it to a virtual network I already have. In your enterprise, you'll probably have a scheme of networks and subnets that you want to utilize. Choose the subnet. In my case, I just have the 10.0.0.0/24 subnet that I'm going to use, and whether or not I want to create that public IP. So I can click here. By default, it will prompt to create it, but I could choose none if I don't want the public IP. So perhaps I'm connecting through my VPN or express route from my data center that I have. Then I wouldn't need a public IP to access the machine, or perhaps I'm using a point-to-site VPN connection to get into the virtual network in Azure. Again, I wouldn't need a public IP, but in my case, I want a public IP so that I can just RDP into it because this is an isolated Azure environment and I'm not connected in via any VPN or express route connection. Then we come across NIC network security group. So again, on a subnet, I can have my network security group and I could just rely on the rules there, but I could also have a network security group associated with the network interface card of the virtual machine itself. Now I can choose not to. If I choose none, you can see that it says all ports in this virtual machine may be exposed to the public internet. This is a security risk. So obviously highly recommend you at least choose a basic one and then choose which ports you want there, or you can choose an advanced one. It takes away that basic option for you there, but you would then configure that network security group more specific to the rules that you want. In my case, I'm going to choose basic. I'm going to choose allow selected ports and select RDP as we previously did. Next, we have an option of accelerated networking. Now, accelerated networking is only available on certain instance types and certain operating system versions. So perhaps you've got Red Hat 7.4 and you wanted accelerated networking. That is available on that machine on specific D-series versions of the instance type. And that allows faster networking between virtual machines that have accelerated networking enabled. Essentially, it bypasses one of the virtualization layers and goes directly to the NIC card and just gives better throughput all around. So that's when you would use accelerated networking. Next, we have load balancing. So if we want to, we can place this virtual machine in the backend pool of an existing load balancing solution. In our case right now, we're not looking to do that or load balance this with other virtual machines. So we will move on to the management section. So under management, you can see here we have a few things. First of all, we have boot diagnostics, so we can opt to turn these on or off. And generally, we just keep them on because it helps us diagnose any problems in the virtual machine. We have OS guest diagnostics. If you covered the monitoring section earlier on in the course or in some of the other videos we have, this is where you can turn on those guest level metrics, or you can just keep them off and just rely on the host level metrics from Azure. And the diagnostic storage account, which is where the diagnostic logs associated with those two things are going to be stored. It will create one for you if you don't specify one. For identity, as will be covered later on in identity, you can assign a system managed identity, automatically for you. And then we have things like auto shutdown. So enabling auto shutdown is something I always recommend you do in your lab environment. Turn it on, choose the time, whatever time zone you're basically in. So in my case, I am in, Central Time right now. So got to go back the other way. So let's go to Central Time. US and Canada, and at 7 p.m. this machine will basically shut off automatically, and that will save me costs in my lab, and I can choose to notify before shutdown or not if I want to. Next we have backup itself. So one of the fantastic features about Azure is you have backup built in, and it's as simple as clicking enable backup, choosing your recovery services vault if you have one, or creating a new one right now, and choosing a backup policy, and there's already some of those already built in for you. So if you do want to back up your virtual machine, all production machines, you should have this turned on by default, especially if you aren't using some other third-party backup solution. But for purposes of the lab, I don't need to back up this machine, so I'm going to turn that off and then move on to guest config. Now, guest config is more focused around things like PowerShell DSC extensions, Chef, Puppet, etc. They're not something we're going to cover right now, but you will see them in a separate module in the course if you haven't done so already. So we're going to move on to tags. Tags are really just a way for us to organize our data. You've probably seen some tag-in demos already, but let's say I just wanted my cost center. In my case, my cost center is lab. I can use this point in time to go ahead and add various tags to my build. Finally, I can review and create, and this is great because it also gives us an option to download the template, and you'll see ARM templates and automation much later in the course, but you can download the template for use in your automation tools right here, before you go ahead and build it. But if you are happy with it, check through everything, make sure everything is as expected, and then go ahead and click create, and that will begin building your virtual machine. Windows machines, B series, take about 5 to 10 minutes to complete. If you choose a D series on premium disk, then they'll be created in much less time. And finally, Linux machines a little bit quicker as well. So plenty of options, but you can monitor your deployment here. You can cancel it during deployment if you want to. You can see the services in Azure that I've already deployed. You'll notice like the IP, the NSG, the disks are all separate services. You can watch them deploy there if you want to. You can also go and see the template on the left hand side. You can still download it here if you want to. You can add it to your libraries if you want to redeploy similar machines. This is a good way to kind of create that ARM template and get it the way you want for deployment later via automation. But with that, this concludes this demonstration, and in the subsequent demos you will see how to connect to your Windows or Linux machines. With our virtual machine now deployed, it's now time for us to connect to the virtual machine itself, and there are multiple ways that we can do that. First of all, let's go over to the Azure portal and create an RDP session to the virtual machine. Here we are in the Azure portal, and the easiest way to find your VMs is either to click the virtual machines tab on the left or go into your resource group, but note that it will show the other associated features with the virtual machine as well. Here we are in the virtual machines tab, and you can see our virtual machine SL-VM01, which is our Windows virtual machine here. Go ahead and click into that. On the right hand side now, you'll see an icon that says connect. Go ahead and click that one. As you can see, it will download an RDP file to your machine. If you open that up, it'll look just like a normal RDP file that would use when you create an RDP connection to any Windows machine traditionally on your on-premises network. You'll get a certificate warning. That's just because we haven't created a certificate for this machine, but go ahead and click connect, and you'll be prompted for your credentials. Now just simply enter the username and password that you used when you created the machine. Click yes if you're prompted for the certificate warning again. And as you can see, we're connected into the machine, and up comes our desktop. So that's one way to connect into our virtual machine. The next way is very similar, but instead of us doing it through the portal itself, let's go and do the same thing using PowerShell. So first of all, let's close out of this RDP session and go over to our PowerShell client. And in this case, we use the following PowerShell command: get Azure RM remote desktop file, followed by the resource group name. In our case, it's SL-70533-VMs, followed by the name of the virtual machine. And then we can add an optional parameter either for launching it directly or saving it locally. In this case, we're going to launch it, hit enter, and you can see immediately we get the connection box pop up and we can go straight into our virtual machine. Alright, so we've seen a couple of methods to connect to our virtual machine via RDP, but it's also possible to connect via WinRM using PowerShell. In order to do this, we have two main methods. WinRM HTTPS. This is where we can connect over SSL using port 5986, and this is the recommended option if you're going to connect over the internet, as it's much more secure. In addition, we have WinRM HTTP. No SSL is required. This uses port 5985, and this is ideal for connections from the same private network which is already secure. There are a number of steps involved in order to set up WinRM. First of all, you have to create a key vault, create a self-signed certificate, upload that certificate to your key vault, get the URL for your certificate from the key vault. So at this point, we've created the key vault, the certificate's in the key vault. Now we get the URL for the certificate directly from the key vault. Finally, we reference our self-signed certificate when we create the virtual machine. All of these procedures can be found at the following link. You won't be expected to know the detailed commands for this, but you should be familiar with the high-level procedures of what's required to create the self-signed certificate. And with that, that concludes this demonstration. In this demonstration, we're going to now connect to an Azure Linux virtual machine. Let's start by heading over to the Azure portal. Here we are in the portal, and as you can see, I've already pre-created a Linux virtual machine, which is SL-Linux VM01. But before we go in and connect, let me show you some of the settings you need to be aware of when you provision the virtual machine. So let's go ahead and click New. And now let's select the Ubuntu server here to deploy. Just like Windows, we have to give it a name, VM disk type, etc. But if we look a little bit further down under our username section, we have two authentication types, SSH public key and password. If we decide to, we can create an SSH public key and paste it in here. But in our case, we're going to use a username and password. So if we go in here, select password, type in our username above, type in our password again, then everything else pretty much proceeds in exactly the same way as we did in the Windows demonstration. I'm not going to deploy this now as I've already pre-created one, so let's close out of this and head over to our virtual machines. Here we are with our already deployed machine. And if I go in here and click connect, you can see that it tells me to use SSH with the following command, SSH sladmin at the IP address. In order to do that, we need to either open up a terminal session if you're using a Mac, or in my case in Windows, I've downloaded PuTTY. PuTTY can be found at the following website, which we'll link in the course material. In my case, I've already got PuTTY installed, so let's go straight over to that and connect to our Linux virtual machine. Here it is on the desktop, double clicking, type in the host name. In my case, I'm going to use sladmin at the public IP address I copied from the Azure portal. Go ahead and click open. It will prompt me for the password. Type that in, and we're now connected in to our Linux virtual machine. And with that, that concludes this demonstration. There are two major choices when we look at VM storage types in Azure. We have standard storage and premium storage. Standard storage is backed by traditional hard disk drives. These are your spinning disks that you have on older machines. They're the most cost effective, but their maximum throughput is 60 megabytes per disk, and the maximum IOPS is 500 IOPS per disk. On the flip side, Microsoft provides an option for premium storage. These are backed by modern-day SSD drives, higher performance, maximum throughput of 250 megabytes per second per disk, and maximum IOPS of 7500 IOPS per disk. If we look at the standard storage sizes, you don't choose your specific size like you would traditionally in a VMware environment on premises. Instead, you choose from the model of disks in your category. So in standard storage sizes, we have S4 all the way up to S50, and they start at 32 gig all the way up to 4095 gig or 4 terabytes. The maximum IOPS for all of the above is 300, and the maximum throughput for all sizes is 60 megabytes per second. Now, if we look at premium storage sizes, a little bit different. These are the P series of disks, so they go from P4 up to P50. They recently added the P15, which is a 256 gigabyte disk in the middle there. The maximum IOPS is 120 for the P4, all the way up to 7500 in the P50. So you can see, even if you've selected your appropriate size, you need to still make sure it's going to meet your IOPS requirements. And that is true for the maximum throughput as well. We could take a P4, but let's say we needed a throughput of 100 megabytes per second. Even though the P4 we only needed 32 gig, we would have to go up to the P10 in order to get the throughput requirements met. So make sure you look at this chart. It's constantly updated on the Microsoft website as you calculate sizes for your disks. Managed versus unmanaged disks is another important thing. On unmanaged disks, this is essentially your do-it-yourself option. You would create your storage account and put your disks in there. There's a lot of management overhead that comes with that because there is a 20,000 IOPS per storage account limit. It does, however, support all replication modes, LRS, ZRS, GRS, and read-only GRS, which we'll talk about in a subsequent section. Managed disks, however, are your simplest option for virtual machines. They're lower management overhead as Azure will manage all of the storage accounts for us. They only, however, currently support the LRS replication mode. This brings us on to replication modes. What's the difference between all of these? Well, LRS is logically replicated storage. This is replicated 3 times within a storage scale unit. A storage scale unit is a collection of racks of storage nodes that are hosted in the same data center in the region as your storage account was created. Zone replicated storage, which is known as ZRS, these are replicated 3 times across 1 or 2 data centers in addition to storing 3 replicas similar to LRS. Data stored in ZRS is durable even in the event that a primary data center is unavailable or unrecoverable. Then we have GRS, geographically replicated storage. This replicates your data to a second region that is hundreds of miles away from the primary region. Your data is curable even in the event of a complete region outage. Then we have read-only geographically replicated storage, also known as RA-GRS. Same replication as GRS we just discussed, but this also provides read access to the data in the other region. It's very important for the exam that you understand the replication strategies. If you take these 3 categories, data is replicated across multiple data centers. Well, the only ones that fulfill that are ZRS, GRS, and RA-GRS. LRS does not support that, it is only local. Data can be read from a secondary location and the primary location. The only option that supports that is RA-GRS. So even though GRS is replicated, we cannot read from the secondary location. This is also known in some cases as it's warm, so recovery time objectives are much better on RA-GRS because the data is already loaded. The number of copies of data maintained on separate nodes is another factor. 3 for LRS, 3 for ZRS, but goes up to 6 for GRS. So just make sure you understand this table, as I think it will definitely help you for the exam. In this demonstration, we're going to add a managed disk to an existing Azure virtual machine. So let's jump straight over to the Azure portal. In the Azure portal, we select our virtual machine, in this case SL-VM02, which is our existing Windows machine we created earlier. Once inside, select disks under the settings category. And here you'll see on the right hand side, we just have an OS disk right now. It's 128 gig. It's using premium LRS storage, no encryption enabled, and its host caching is set to read-write, which is the default for all OS disks. Now we want to go ahead and add our data disk. So click Add Data Disk. And on the bottom here, you'll see your LUN0 and the name of the disk. Select Name, and choose here. You can choose an existing disk, or we can choose to create a new disk. In our case, we want to create a new one. So here we go, Create Managed Disk comes up, and we'll give the disk a name. SL-VM02 Disk 2 in my example here. We're going to use our existing resource group. We want to keep all the resources with that VM together. If we want to delete everything, we can just delete the resource group and everything contained in there will be deleted. Our account type, again, we can choose premium or standard for our disk type. We're going to stick to SSD drives here. Source type if we wanted to, if we expand this out. This allows us to create a disk off a snapshot or a storage blob. But in our case, we're creating an empty disk, and then we choose our size. As you saw with the premium disk sizes in the PowerPoint presentation earlier, the size affects the IOPS and throughput below. What's great is Microsoft puts this directly on screen for you. So if we drop this down to a 256 gig disk, we'll see the IOPS and throughput drop. If we go up to, say, 2000 in size, we'll see it increase again. So you can still choose the disk size, and it's going to select the underlying premium type disk that's appropriate for your disk size. Go ahead and click Create, and in a little while your managed disk will be successfully created. We'll fast forward ahead here. Now that disk has shown up, I've gone ahead and clicked Save at this point, and it's now updating the VM configuration with the disk. So first we created the disk. Now we have to save the settings here so it's associated with the virtual machine. And as you can see, it successfully updated virtual machine disks. So now if we log into the virtual machine, we've got an RDP session already open. Scrolling here, in fact, yep, we can see it's already come up there, 2000 gig. Now if we right click, create a new simple volume, this will guide us through the Windows wizard, just like you normally would add a disk. Comes up with the size, we can choose to allocate all that size or not. Go in here and choose the drive letter, in this case we're going to have the F drive. Click Next, 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 hit Finish. And Microsoft is now formatting that disk, and it'll be available for us to consume in Windows once that's completed. And with that, that's the end of this demonstration. Disk caching is another feature on the exam that you need to become familiar with. It's a method for improving performance of existing virtual hard disks. So rather than maybe upgrading your disk to premium and moving your data across, disk caching can provide you some additional benefits. It utilizes local RAM and SSD drives on the underlying VM host. So the RAM and SSD drive it utilizes is actually local to that specific host that your virtual machine is running on. This gives us increased performance versus it having to transfer to the SAN-based type array systems. It's available on both standard and premium disks. There's a couple of settings you need to be aware of here. On the OS disk, read-write is the default, and you can change that to read-only or read-write, but it is recommended to stick to read-write for your OS disks. Data disks, whenever you add them, have a default setting of none, but you are allowed to change that to read-only or read-write as well. Read-only caching will improve latency and potentially gain higher IOPS per disk for all read tasks. Read-write caching, same thing, it would help with the write caching as well. However, you need to be sure you have a proper way to write data from cache to persistent disks, otherwise you could potentially get some data loss. There are certain use cases that this works for and certain that it doesn't, so check with whatever software product you're using if it supports read-write disk caching. For the most part though, if you do have a lot of read tasks, turning on read-only caching for your data disks will give you improved performance. In this demo, we're now going to